Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solutions for systems of equations. This is standard A.3F in the great state of Texas, and we're using item number 29 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have a line here that's already graphed, and it represents the first of two equations on a system of linear equations. So the second equation on this graph passes through these 2 points. All right, so let's put these on the graph here. Negative 12 is our x, 20 is our y, so it looks like it's going right up there. Okay. And then 4, 12, 4 is our x, 12, interesting. All right, so which statement is true? Well, if I were to draw a line here connecting these two, I'm going to try to make it as straight as possible, but I don't have a straight edge. You know what? If I drew it correctly, that looks like that is never going to touch. It looks like these are parallel. Let's see if we can see exactly how. Look at the distance here. So this right here is negative 12, 20, right? That's what I put there. This is my 4, 12. Look at how far apart it is from the line below. This looks like it's 4, 8. So you see the x is obviously the same. There's a difference here of 4 between the y values. And this looks like it's negative 12, 16. Once again, x's are the same. It's the y values that are 4 apart. So it looks like it's the exact same distance apart. You know what? We could even find the slope, right? The slope remembers the change in y over the change in x. So let's make this x1, y1 and x2, y2. So that's going to be 12 minus 20. That's going to be 4 minus negative 12. So negative 8 over 16. Okay, so I don't know why I wrote 12. It's negative 1/2 there. There we go. So this is a negative 1/2 slope. Let's see what it's like for this second line, the one that's already there. We'll make that x1, y1, x2, y2. All right, so that's going to be 8 minus 16. That looks like it's going to be a negative 8 again. And then I've got 4 minus that negative 12. So that's going to be negative 8. Look at that. We've seen this before. All right, so we've just shown that these two lines have the exact same slope for both M1 and M2. Okay, so that did verify that it's the same distance apart. So these are going to be parallel lines. What do we know about parallel lines, and specifically about their solution? Okay, well, let's just look at these 4 answer choices because the answer is going to be kind of obvious. The only solution to the system is 10, 5. All right, so where's 10, 5? 10, 5 looks like it's on this bottom line, but you know what? It's not a solution unless both lines intersect at that point. The top line does not intersect at that point. They never intersect. So that's not a solution. The only solution to the system is 0, 14. All right, 0, 14 looks like it's the y-intercept about for that second line. But the first line's y-intercept is 0, 10, so it's not a solution because they don't intercept. The system has no solution, has no interceptions. That makes sense. The system has an infinite number of solutions. That would be if both lines are on top of each other. They're called corresponding lines. Instead of being parallel, they're literally the exact same line, one on top of each other, and every single point is a solution. That is not the case. My answer is C because they're parallel.